One of the most fundamental ideas in modern mathematics is that of the expression. In fact, ever since you learned to take numbers and combine them with operations to produce new numbers, you've been working with expressions. What we're going to do today is focus on the way expressions are written and make sure the way we show our working makes sense, that someone else reading it can follow and understand what we've done. A numerical expression is a combination of numbers and operations, which represents a numerical value. To evaluate an expression means to determine that overall value. When evaluating expressions, we follow the order of operations. So to help us remember the order of operations, we're going to use GEMDAS. Now you may have already learned this as PEMDAS, using P instead of the G that we have here. The reason for this change is that parentheses are not the only thing that can be used to group things together. Parentheses do that, but we can use these other symbols such as brackets, braces, absolute value bars, radicals, and fractions to group things together. So instead, we'll use G for grouping symbols. The following letters in GEMDAS are E for exponents, M for multiplication and D for division, and A for addition and S for subtraction. Notice with the way we've written it here that M and D are in the same level and A and S are in the same level. We don't do multiplication before division or addition before subtraction. These are always done within the same step, working from left to right. Now to show you're working clearly, you should write your calculations one step at a time. We use the equal symbol to indicate that expressions are equivalent. You should always work vertically, with all the equal signs written in a straight line. Let's practice evaluating some expressions, but also practice writing our working correctly. So for this expression here, let's work through the order of operations to decide what to do first. Our first letter is G for grouping symbols, and we notice we have some parentheses here. So that tells us we need to evaluate this first. 8 subtract 3 is 5. So what I'm going to do is write out the entire expression again, but replacing those parentheses with the value that they evaluated to, 5. Now the next step in our order operations is exponents, and we have an exponent. So we have 5 to the power of 2, which is 25. So we evaluate that, and the rest of the expression is written out the same way. Notice my equal sign written directly below the one that I already had before. The next step is multiplication and division. So we work these from left to right. 3 times 25 is 75, and 5 times 7 is 35. I can do these in the same step here because they're in separate terms separated by the subtraction that we have. Finally, 75 subtract 35 is 40. And that is the final value of our evaluated expression. For our next expression, we do have some parentheses again. But notice the role of these parentheses is a little bit different. They're not here to group two numbers together with an operation. They're grouping a negative with the number that follows it. So we don't actually need to do anything with these parentheses. However, there is another grouping symbol here. The fraction can only be evaluated once the numerator and denominator are each evaluated separately. So let's follow the order of operations to evaluate both of these. In the numerator, there's no exponents, but there is a multiplication, so we can do that. 3 times negative 6 is negative 18. In the denominator, again, there are no exponents, but there is multiplication. So 5 times negative 3 is negative 15. In the next step, we can evaluate the subtraction in the numerator and the addition in the denominator, which gives us 22 divided by 2, which evaluates to 11. Evaluating exponents. We spent a lot of time in our previous unit looking at exponents and how to evaluate them. But let's look a bit more precisely here at what happens when we have a negative number. We need to be a little bit careful here with how we choose to evaluate these. Now notice we don't actually have any negative exponents in these examples. It's not the exponent part that's negative. So that's a little bit different for how we work with negatives previously. So this first expression, we have negative 2 in parentheses, and then that quantity is to the power of 3. That means our base is negative 2. So this is negative 2 times negative 2 times negative 2. If we evaluate this, negative 2 times negative 2 is 4, times negative 2 again is negative 8. Now the next expression, where we have a negative in front of 2 to the power of 3, is a little bit different. 2 to the power of 3 is 2 times 2 times 2, and then we have a negative in front of that. Notice our order of operations without the grouping symbols tells us to do the exponents first. So that's what we do, and we get the answer, negative 8. Now notice the way we evaluated these two expressions was different, but we still ended up with the same answer anyway. So does it really matter how we evaluate these? Well, let's look at the next two examples where we have a different exponent. So again, I've got in parentheses negative 2, and then that's to the power of 4. So like before, this means our base is negative 2. So we need to evaluate it by multiplying negative 2 by itself. This time we have it 4 times. So negative 2 times negative 2 is 4. Multiply by negative 2 again, we get negative 8. And multiply by negative 2 again, we get 16. Notice this one is positive 16. Now if we have a negative in front of 2 to the power of 4, like before, the negative is no longer part of the base. So we have 2 times 2 times 2 times 2 with a negative in front. So this is negative 16. Now have you noticed what's different about these expressions? Why with the power of 3 we ended up with 2 negative answers, and with the power of 4 we ended up with a positive and a negative answer? The reason for the difference is that 3 is an odd number and 4 is even. Each time we multiply by a negative number, the value alternates between positive and negative. If we do that alternating an odd number of times, we're going to get a final value that's negative. But if we do it an even number of times, we'll get a value that's positive. In general, a negative base to an odd power is always negative. A negative base to an even power is always positive. But if a negative sign is not contained in grouping symbols with the base, it's not part of the base and will be evaluated after the exponents. Let's do some further examples. So if I have negative 3 in parentheses to the power of 4 plus negative 4 in parentheses to the power of 3, let's evaluate these one step at a time. So we can do our exponents first. Negative 3 to the power of 4 will be positive because that's an even power. So this is 81. Negative 4 to the power of 3 will be negative because it's an odd power. So that's negative 64. And we can add those to get 17. For our next example, we have negative 3 in parentheses to the power of 2 plus negative 3 in parentheses to the power of 4, subtract 3 to the power of 4. Negative 3 to the power of 2 is 9 and positive because it's an even power. Negative 3 to the power of 3 is negative 27, negative because it's an odd power. And then finally, notice that our last term here doesn't have parentheses. So the negative isn't part of the base that's raised to the power of 4. So 3 to the power of 4 is 81, but this term is still being subtracted. Now 9 plus negative 27 is negative 18, and then subtracting 81 from that gives us negative 99. Expressions represented with words. Now one of the big advantages of using expressions is we can write them down in a very precise way and make it really clear what our intention is, what we intend to be calculated. However, we don't always get the opportunity to do that, and sometimes we need to describe what we're doing using words instead. So we're going to spend some time practicing how we take an expression described in words and write it down with more typical mathematical notation. Now you can see in the table that we've got a list of different words that are associated with some of our common operations. Note that this isn't an exhaustive list. There are many more words that we could use to describe each of these things. But let's jump into the examples. So the quotient of 20 and 4. Quotient is the result of division, so this is really 20 divided by 4, which is 5. 25 less than 8. Now be careful with an expression like this. We actually need to switch the order of our numbers when writing the expression down, because less than implies that we're taking 25 away from 8. So 8 subtract 25 is negative 17. Twice the difference of 13 and 9. So firstly, the difference of 13 and 9 is 13 take 9. And then we need to multiply this by 2. Because the order of operations says to do multiplication before subtraction, we need to include grouping symbols, such as parentheses, to make sure that we do the subtraction first. 13 take 9 is 4, and 2 times 4 is 8. 10 more than the product of 9 and 7. So firstly, the product of 9 and 7 is 9 times 7. Then we can find 10 more than the product by adding 10. This time we don't need grouping symbols because the order of operations is already correct for what we have written down. So 9 times 7 is 63, and adding 10 to that gives us 73. Half of the sum of 14 and 8. So the sum of 14 and 8 is 14 plus 8. Then we need to divide this quantity by 2. Now we could write parentheses around this quantity and then write divided by 2. But don't forget that a fraction is a grouping symbol. So instead we can actually write it like this, where we make 14 plus 8 the numerator and 2 the denominator. 14 plus 8 is 22, and then dividing that by 2 gives us 11. The sum of 14 and half of 8. Now notice this is describing the exact same operations and the same numbers as the last example. But the wording changes the order we're doing those operations in. So firstly, half of 8 is 8 divided by 2. And we want the sum of that with 14. So that's 14 plus 8 divided by 2. 8 divided by 2 is 4, and 14 plus 4 is 18. 7 subtracted from the square root of 16. So we can write down the square root of 16 like this using a radical sign. And then we need to subtract 7 from this. Now be careful, it would be tempting to put 7 take the square root of 16 because those are the orders the numbers are in the description. But notice that it says 7 is subtracted from the square root. So we need to write it like this. The square root of 16 is 4, and 4 take 7 is negative 3. And finally, the square of the quantity 18 minus 7. Now those words, the quantity, are very important here. They're almost doing the work of parentheses for us, in that they're grouping numbers and operations together and saying we need to do those first. If this just said the square of 18 minus 7, that would mean we square 18 and then subtract 7. But those words, the quantity, means that we need to do 18 subtract 7 first. So we write that in parentheses and then we square. 18 take 7 is 11, and 11 squared is 121.